the continuation of Diana's bago discussion for soldering. So, overheated joint. At the other extreme, we have the overheated joint. The solder has not yet fluid will and the residue of burn flux will make fixing this joint difficult. Repair. An overheated joint can usually be repaired after cleaning. Careful scraping with the tip of a knife or little isopropyl alcohol and a toothbrush will remove the burnt flux. Prevention. A clean hot soldering iron. Proper preparation and cleaning of a joint will help prevent overheated joint. Soldering equipment. Soldering iron. Soldering iron is probably the most essential instrument for soldering. Nowadays, there is a huge selection of soldering irons of different kinds, but we would like to highlight the following ones: traditional soldering iron, USB soldering iron, gas-heated soldering iron, temperature-controlled soldering iron. The first one is traditional soldering iron, a well-known and widely used instrument for soldering. When choosing the when choosing the traditional iron, pay attention to its wattage. To solder electronic components, you would need 25 to 40 watts soldering iron. For the household use, pick 60 watts one. In case you need to solder massive details or elements like thick wires, jet metal, etc., consider buying the soldering iron with a higher wattage of at least 100 watts or more. The second one is the USB soldering iron. One of the novelties of the modern soldering equipment market, you might not believe, but the 8 watts USB powered soldering iron is a perfect choice for almost any small soldering job you can think of. But let's look at the particular model. For example, the Prosket SI168U. One of its most distinctive features is that it's powered through the regular USB port. Therefore, you can easily charge it with, for example, a power bank. Because of this, the USB soldering iron is a portable and very easy to hold or carry around device. The second one is the gas-heated soldering iron, another portable device. Um, sorry. The third one is the gas-heated soldering iron. Another portable device is um, another portable device. Compared to the USB soldering iron, the gas-heated one is much more powerful, therefore more suitable for heavy-duty soldering of thick wires, copper tubes, and jet metal. It also has a special feature. It can be used as a regular heat gun. One of the most popular models of gas-heated soldering irons is called GP510 set, which sets apart from the others due to its high quality and modern design. The last one is the temperature-controlled soldering iron. Compared to the traditional soldering iron, the temperature-controlled one is undoubtedly more versatile, featuring 60 watts ceramic heater as well as a temperature controller in its handle. This soldering iron is suitable for both lead-free and regular lead soldering. The, vari- the variety of temperature-controlled soldering irons is quite wide, from the low-end models to the expensive models for professional use. And then the soldering station, an indispensable instrument for soldering and electronics repairs in general. Soldering stations feature galvanic isolation that provides extra safety during the soldering. Also, compared to the traditional soldering iron, soldering stations allow you to control and adjust the temperature of the tip more precisely. There are two soldering station, which is the contact soldering station and the hot air soldering station. Preheaters. If you are using the hot air gun to heat the electronic components, eventually you may face the issue of overheating. To minimize the rest of components deformation or damage due to the temperature differences, we recommend using the preheaters. The preheaters are used to ensure even preheating of the PBCS, which is very useful when working with the IC chips. Then the soldering pump are useful are, are are super useful when working with the IC chips and the DIP packages. There are few ways of removing the leftovers of solder. You can do it using tons of desoldering wick, which is economically inefficient. You can use the hot air gun for it, which is quite risky as you can overheat the microchip, or you can simply use the desoldering pump and suck the solder up and out of the way quickly and easily. Soldering iron tip cleaner. The soldering iron tip cleaner. Although the soldering tips are robust, they do require a small amount of maintenance, especially if you want them to have a long service life. Therefore, during the soldering process, you need to clean them from any accumulation of carbon and old solder. To clean the soldering iron tips, you have two options, the cleaning sponge or the special dry cleaner that consists of soft metal shavings. The cleaning sponges are quite cheap and practical. However, be prepared that using them will cause the soldering tip to lose its set temperature. To avoid this, use the second option, the dry cleaner, which is much more durable and allows for quality cleaning. The Japanese company Good is considered to be one of the best manufacturers of high-quality cleaning products for soldering tips. Tweezers. Tweezers are great. You can use them to keep components in their place and to avoid burning your fingers when soldering. If you ever soldering surface mount components, these are very useful for placing small components. USB microscope. Microscope has been invaluable in some debugging situations with fine pitch components. With this, you can, for example, discover the tiny solder joints between pins that are not supposed to be there. This is also very useful for people who has problems with the eyesight. So steps involved in the wave soldering process. Step 1. Melting the solder. This is very first step in the entire wave soldering process. It is the basic requirement of the process to melt the solder. The wave soldering machine has solder contained in a tank. The tank is heated to melt the solder. Appropriate temperature is reached to meet the right consistency so that the process of soldering can be carried out further. Step 2. The cleaning the components. This is a very crucial step to be carried out. The components to be soldered are cleaning thoroughly in this step. If any oxide layers are formed on the components, then they are removed. This is done by the process called fluxing. There are two main types of fluxing, the corrosive high acidity and non-corrosive high acidity. Step 3. Placement of PCB. After melting the solder and cleaning the components, you need to be soldered. The printed circuit board is placed on a melted solder. The board is held with the metal clips of the machine, which ensure the firm positioning and placement of the PCB. Step 4. Application of solder. Now that the PCB is placed properly, molten solder is applied and is allowed to settle. Sufficient time is given to this step to allow the solder to settle into the joint completely and ensure no bumps are formed. The last step is step 5, cleaning. This is the final step in the wave soldering process. Any flux residues formed during the process are cleaned in this step. The circuit board is washed and cleaned with the help of the ionized water and solvents. I will show a short video about soft soldering.
This video shows basic soldering technique and the equipment used to solder. There are two main types of soldering iron. The iron to the right has a station which shows the temperature on the display. The controls adjust the desired target temperature. The one on the left works at a fixed temperature but is used in the same way. If you're using a digital iron, then set the target temperature to around 350 degrees C and wait for the iron to heat up. When you're not soldering, remember to keep the iron in the holder. Be careful when you're soldering not to put the iron in contact with the lead. Some soldering irons have PVC coated leads which will melt through easily and pose a risk of electric shock if touched. The best leads to use are made from silicon, which won't melt at the temperatures soldering irons reach. The other item you'll need is of course solder. Solder is a low melting point alloy which flows easily when heated to its liquid state. When it cools and solidifies, it fuses to the surface of a metal at the molecular level, providing good electrical conductivity between two metal surfaces. Solder normally contains flux, which helps the solder to flow, and also helps make a good contact by removing the oxides on the surface of the metals being joined. Although modern flux is not toxic, when soldering you should always use a fume extractor to prevent the fumes from the flux irritating your lungs. The fumes are extracted by a high-efficiency particulate air filter, or HEPA filter, before the air is returned to the room. Before you handle the components, it's strongly advised that you wear an earthing band to prevent electrostatic damage to the components. There are two different soldering types, surface mount and through-hole. Surface mount connections are made by heating components with pre-applied solder in an oven so that it melts and joins to the surface of the board. For this tutorial, we'll look at plated through-hole soldering, which is done on boards with printed circuits on both sides. Through-hole soldering is when components are pushed through a hole in the board and soldered from the other side. The solder flows through the hole to make the best possible contact. First, take your component and create a bend in the legs with a pair of pliers, so that each leg is at a right angle. Push the legs through the holes in the board at the appropriate place and push it all the way down. Then turn the board over and bend the legs slightly to lock the component in place. When the iron is up to temperature, first clean the tip of the iron on the wet sponge on the iron holder to remove any excess solder and flux residue that might be there. You then apply heat directly to the pad for about a second, before placing the solder in contact with the pad. When the solder starts to melt, feed it in for about a second. Take the solder away, but leave the iron on the pad for another second. Then take the iron away and let the connection cool. Let's have another look at that. Before you make another connection, it's important to remove any excess solder remaining on the tip of the iron. This is because any flux in the solder will vaporize until there's none remaining. If you try to make a connection with solder without any flux in it, you risk making a bad connection. When you turn the board over, you should see that the solder has flowed through the hole by capillary action, guaranteeing a good contact. Trim the leads just above the solder using some wire cutters. When you cut the wires, be careful that the cut end is held captive so that it doesn't fly off. This can be done by putting your finger on the end when cutting. If you make a bad joint or want to remove a component, you can remove the solder by using a desoldering pump. This is a spring-loaded piston with a trigger which when released creates a vacuum which sucks the solder up. Cock the pump. Use the iron to melt the connection and put the tip of the pump onto the melted solder, then release the trigger. You might have to repeat the operation several times to clear all of the solder. An ideal solder should look like a cone with slightly concave sides, showing that the solder has flowed through the hole. You can see all the solders here look regular. Bad joints are noticeably different to the concave cones of good joints. If your joint looks like any of these, then it'd be wise to remake it. Bad joints can lead to intermittent connections or no connection at all.
So that's all for my topic, which is soft soldering. Thank you for watching.